So the endosymbiont theory explains how we get more complex cells from prokaryotes. And remember, prokaryotes have their own DNA. They have their own genetic information. So I'll draw that in here. And prokaryotes also come in many shapes and sizes. So I have a larger one and I have a smaller one. The larger one I will label prokaryote 1, and then the smaller one I'll label prokaryote 2. And something that's important to remember about prokaryotes 1 and 2 is that they can function independently. They live independently. They don't need one another. They're each living on their own, which means they are using their own genetic information, their own DNA, in those circular chromosomes. And they have their own methods for obtaining energy. So what the endosymbiont theory is basically saying that to get a eukaryotic organism, we need one prokaryote, which in this case I'm going to use as prokaryote 2. We need that prokaryote to go inside the other one and develop a mutualistic relationship. So these two are probably just carrying on their natural way of doing things that they've been used to for hundreds of thousands of years. In one instance, though, when prokaryote number 2 touches the membrane of prokaryote number 1, it starts to be engulfed. It starts to be taken in by prokaryote number 1. Because what's happening here is prokaryote number 1 is allowing its membrane to fold inwards, and that pulls prokaryote number 2 further in. So I'll be drawing this out as a series of steps, but here would be a good time, if you're just reviewing the video, to put it at faster speed. So over time, prokaryote number 2 is being internalized by prokaryote number 1. So the last step in this process of internalization is going to be when the sides of the membrane from P1 meet back up with each other behind the back edge of P2. Then you have P1 completely enveloping P2. An important note to remember, however, is that when prokaryote 2 is completely enveloped by prokaryote 1 and becomes an internal component, prokaryote 2 has wrapped itself in a part of prokaryote 1's membrane. So surrounding the original membrane of prokaryote number 2, we now have another outer membrane that has been created from the infolding of prokaryote number 1's cell membrane. So for the purposes of the labels here, I will label the black circle, that original membrane, I'll label that the inner membrane, and the orange circle, which is representing the part of the P1 membrane that P2 brought inside internally with it, that I'm going to label as the outer membrane. Under this sketch, I want you guys to write some very important things. The first thing is that over time, P1, prokaryote 1, is going to rely more and more on the energy produced by P2, prokaryote number 2, and that's the one that's been internalized. So P1 is going to be relying much more on P2 as time goes on. So as a result, P2 is going to become an organelle that works for P1 to produce its energy. And an important thing to note is that this organelle is going to be membrane bound. And if you go back to our prokaryotic versus eukaryotic cell notes, you will remember that membrane bound organelles are a characteristic of eukaryotes. So this process, endosymbiosis, is how we got our early eukaryotic organisms. So I will cross out the labels for prokaryote 1 and prokaryote 2, and now instead we have one single ancient eukaryote. This is how cell complexity has evolved.